From towering cranes on the skyline to powerful tunnel boring machines that carve pathways beneath the earth, these giant machines turn visionary designs into concrete reality. Join me, I'm counting down the top 15 most amazing infrastructure building machines. Starting with number 15, STIM Street Painters. So, as far as street painters go, nothing really is like the STIM street painting machine. It's produced in Belarus. These machines use a paint made out of thermoplastics and reflective glass beads to create road markings that are long-lasting and visible. While they have several different machines, their Contour 700 TPK is one of the most futuristic. It can be used without a driver or operator. STIM also offers the Schmel 12A, which is the size of a cargo truck and meant to paint major roadways and highways, and the smaller Kentur 100, which is perfect for inner-city roads. Number 14, the Track Laying Machine. Well, in recent years, China has been building, and it's because of this that the hopes are for it to be widely used in alpine and high-altitude regions, where there's a shortage of labor. Number 13, the Doosan DX800 LC7. Well, with a name like that, it's gotta be great, right? Well, it comes in at a weight of about 72 tons. The massive Doosan DX800 LC7 is one of the best excavators out there. It's powered by a 530 horsepower engine. It's got 3 excavator arm options to perfectly suit the task at hand. And the machine also has a unique double boom foot design that improves stress distribution, reduces single side wear, and increases your uptime. While operators can choose between a boom and swing mode, with the boom being best for harsh conditions while the swing is better for lighter duty. To top all this off, the machine is controlled with the help of a 20-centimeter touchscreen LCD monitor, making it a truly high-tech and top-of-the-line vehicle. Number 12, the Hitachi EX8006. Well, Hitachi is well known for its comfortable cab, advanced hydraulics, and a tough frame. It makes it an elite vehicle. Number 11, the Tiger Stone. Well, paving bricks by hand is a slow process. However, the Tiger Stone makes the work go a whole lot quicker. It works by having 1 to 3 human operators stand on its platform and feed loose bricks into the machine's sloping pusher slot into the desired position. The power of gravity then slides them together into one road-wide sheet onto the sand below, and once a tamper goes over them, the bricks are set in place. Since the Tiger Stone is electrically powered and contains few moving parts, noise and maintenance are quite low. Reportedly, even with just 2 operators on board, the machine can pave at least 300 square meters of road per day. Given the fact that 2 conventional pavers doing hard labor on their hands and knees can only manage between 150 and 200 square meters per day, this is quite impressive. Number 10, the V420 skid loader that powers it. To top this off, the machine is quite comfortable, as it features heating and air conditioning, of course, a 14-pin connector that can support several attachments, and 2 speed operations for travel around the job site. Plus, Gell's patented Hydroglide for a smooth ride and low material spillage. Now, it is worth noting that while the V420 is impressive, it's not perfect. After all, skid rollers generally have to be compact in order to properly clear an area, making the V420 only suitable to the largest of projects. However, for laborers working on a major piece of infrastructure, the V420 is the perfect vehicle. Number 9, the Iron Monster. Well, it's known locally as the Iron Monster. This bridge-building machine may just be one of the most colossal vehicles on this list. Designed by the Xizhanghuang Railway Institute and manufactured by the Beijing Wao Joint Machinery Company, the Iron Monster, which is more formally known as the SLJ 932, constructs long bridges with numerous spans. After all, while a human crew is still necessary to both oversee the process and provide maintenance, the labor is far less intensive. It's also proven to be efficient, and given its massive 580-ton size, it's able to deal with heavy loads. Now, it should be noted that these machines aren't perfect. After all, the Iron Monster can lay somewhere between 700 to 1,000 bridge spans before needing to be replaced, giving it an operational lifespan of about 4 years. So, some more money will have to be put into its longevity if this incredible machine is to become more mainstream. Number 8, the Yongzhou. China is in the middle of creating what will arguably be the world's longest undersea high-speed railway tunnel, and the Yongzhou is the machine that will be behind much of that work. The Shield tunneling machine rolled off the production line in February 26th of 2024, making it one of 2 Dragon-themed tunnel boring machines to be made for task. According to the Chinese state media, it was given the Dragon of Fortune water stretch, which is 23 kilometers long and passes under the Tsugaru Strait. The Channel Tunnel, which connects England and France, has an even longer underwater section, with this coming in at a length of about 38 kilometers. Yet both of these rails have a max speed of about 160 kilometers per hour, making them far slower than their Chinese counterpart. However, what is certain is that because the Chinese underwater tunnel is part of a larger network that's 76 kilometers long and designed for speeds of up to 250 kph, it will officially be the world's longest high-speed railway tunnel with an underwater section. Furthermore, the cool dragon-themed tunnel borers they're making with it have a bit more flair than most of the other machines on this list, and they look pretty cool too. Moving on to number 7, the Saren's SGC-250. So cranes are easily one of the most important machines at a port. They're necessary to move material to different levels and floors of a ship. And of all the cranes out there, the Saren's SGC-250 is chief among them. It's launched at the port of Ghent in Belgium on 60 meters, and if necessary, this can be extended by another 100 meters or so, making a max height an incredible 250 meters. When combined with its ability to move around a worksite, this flexibility allows it to do practically any job at the port, while its ability to operate on 2 hook blocks, one on the main boom and one on the jib, makes it exceptionally efficient. The reason why it was built is all thanks to a trend towards the company's clients wanting to use large pre-assembled portions when putting things together, rather than work with small pieces. This in turn necessitated a larger crane, which Saren certainly delivered on with this vehicle. Now, while the crane was first located in Ghent in 2019, it was moved over to Hinkley Point C, which is near Somerset in southwest England, and is the site of a new nuclear power plant. And while only one version of the crane has been built at this time, if it continues to perform well, I'm sure more and more of them will be built for willing customers. Number 6, the Falcon Heavy. While most major infrastructure exists, on Earth, in recent years Merlin engines work in tandem to generate more than 5 million pounds of thrust at liftoff. And best of all, it's reusable, so it helps its economic viability, and in total, it's had 9 successful launches and several reflights. In terms of its payload, it can fit practically anything, and there have been some pretty cool items on board. For example, on its maiden voyage in 2018, the Falcon Heavy brought a Tesla Roadster into orbit. In 2022, SpaceX began launching the U.S. Space Force's top-secret satellites, and in 2023, the Falcon Heavy launched NASA's Psyche probe on its mission to study planetary cores. However, it's also worth noting that a successor to the Falcon Heavy is currently in the works. Considered to be the largest and most powerful rocket ever flown, it should be able to make space development even easier. Yet, while it's set to begin operation in 2026, things haven't been going all that smoothly. After all, the first test flight led to the ground control losing control of the vehicle, and the second led to a massive explosion and multiple engine failures. So SpaceX still has some more. Built Robotics was one of the first players on the scene, and they first began testing autonomous excavators in 2017. As time went on, major companies like Caterpillar in the US, Doosan in Korea, and Volvo in Europe started experiments with fully autonomous heavy-duty machinery. However, the unfortunate reality is that the idea has yet to advance beyond the prototype stage. The reasons for this are primarily due to the complex nature of construction sites. Automation is most successful when carrying out repetitive tasks with predictable outcomes. This is why driving, where most public roads have similar rules and layouts and major accidents are few, it is workable. However, construction sites have multiple 3D objects that change from site to site and building objectives that change given the project. This in turn makes using an autonomous machine relatively difficult. To date, if the idea does get off the ground, it's likely Caterpillar, which is the world's largest construction equipment manufacturer, they'll make it happen. They began experiments with autonomous trucks all the way back in the 1990s. 4. Big Bertha. Creating a massive underground tunnel is no easy task, and so when the Washington State Department of Transportation needed to make a 3.2-kilometer double-decker tunnel as part of State Route 99, they decided to bring in Big Bertha. Designed specifically for the creation of the tunnel, she was sent to Seattle in a set of 40 6,100-ton pieces, and once assembled came in at a massive 17 meters in diameter and set the world record for having the widest cutting discs ever. Yet despite being a very impressive piece of machinery, almost immediately Big Bertha ran into some problems. That's because after completing just 11% of the tunnel, all work came to a halt. That's because it became apparent that several cutting blades were damaged, and at first it was believed that this happened after the blade struck a steel pipe that had been used to measure groundwater in 2002. However, a subsequent investigation found that it was not the pipe, but overheating that caused the damage to the main bearing seal. In order for the work to continue, the massive head of the machine, such a disastrous operation did not come without its legal challenges. More specifically, the state of Washington sued contractors Seattle Tunnel Partners, who were paid $1.35 billion to construct the tunnel, for the delay and their lack of action upon noticing the pipe that was believed to have caused the delay. Once all was said and done, they were forced to pay a whopping $74 million in damages, making it quite the payout to Seattle. Number 3. House printers. So while most 3D printers make small objects, there's been a growing trend of using 3D printers to make high-quality homes efficiently. One of the first companies to really put the idea into motion was SQ4D. Located in the state of New York, the company uses an autonomous robotics construction system, which is also known as an ARX printer. It brings this printer, a pump, and a volumetric mixer on site to construct the home using 3 simple raw materials: sand, water, and Portland cement. Come from 3D printing, a 130 square meter home with a detached garage in the town of Riverhead, Long Island, was listed for a price of just $299,000, putting it at almost half the average price of a similar home in the area. Ever since, 2 more of these homes have been built and leased out to the curious as short-term rentals. While SQ4D did solve the problems of price and efficiency, researchers with the University of Maine have taken things a step further by creating a 3D home that's both larger and greener. Known as BioHome 3D, it's the first 3D home to ever be built using exclusively bio-based materials. The idea comes from the simple fact that Maine not only has a housing problem, but a material surplus. After all, due to a decrease in the use of paper mills, there's now over 1 million tons of waste wood residues per year that's simply wasted. It was this residue, along with plant resins, that was made to make super fashionable 600 square foot homes. What now needs to be determined is whether or not these houses will stand the test of time. Now, as you might expect, quite a few of these in development. Tesla's Optimus is perhaps the most famous and controversial of the bunch. Featuring a fully humanoid head and self-driving torso powered by 40 electromechanical actuators, it will reportedly be able to carry a maximum of 20 kilograms, making it strong enough to make its way around a job site. At 173 centimeters in height and 57 kilograms in weight, it will be the approximate size of an adult human. And while this might be a bit scary, Elon Musk has promised that there will be some limits on the machine. More specifically, he said that its maximum speed will be a paltry 8 kilometers per hour. And despite its size, it will be weak enough for most humans to easily overpower it, just in case the machine goes haywire. Musk also said that, quote, "It's intended to be friendly, of course, and to navigate through a world built for humans and eliminate dangerous, repetitive, and boring tasks," end quote. And he hopes that in the future, physical work will be a choice. In theory, Optimus could very well do building infrastructure. One of the key advantages of using Optimus is its ability to perform tasks. At this point in time, the whole thing was a bit of a disaster. After all, while the Optimus was able to wave to an audience, it couldn't even walk. Yet ever since, there's been some major improvements to date. The Tesla Optimus is reportedly able to self-calibrate its arms and legs and perform a yoga pose. The hope is when it's finished development and out for production, these robots will cost less than 20 grand a pop, making them a cost-effective substitute for us humans. However, this doesn't mean that the Optimus is completely out of the woods just yet. That's because recent development suggests that the Optimus may not be meeting expectations. First and foremost, it seems that Musk's prediction that we'll be ready to ship by the end of this year is bogus. And while he recently claimed that it is, quote, "the most sophisticated humanoid robot that's been developed anywhere in the world," end quote, the reality is this simply isn't the case. For example, humanoid robot maker Figure AI just signed an agreement with BMW and is hoping to ship this year. Meanwhile, companies such as Apptronic and Agility Robot After all, there are many who see Optimus as a threat, believing that the existence of these machines on the mass market could only lead to widespread trouble. And if they're able to replace construction workers as well as tech CEOs think that they will, all of the people put out of a job will be left out to dry. I don't want that to happen. Number 1. Swarm robots. When you think of swarm robots, chances are a plethora of little robotic machines comes to mind. And while that may sound absolutely terrifying, it turns out that these little guys may be the future of infrastructure. In essence, swarm bots are construction robots that increase safety on construction projects by completing tasks that are deemed unfit for a human. The idea behind them is to use a swarm of simple robots to build a design, often in an autonomous way, much like termites building a mound or bees a hive. Functionally, engineers want these machines to work in the same way using AI framework, where their rules of operation are set before the job begins. That can build modular block structures much larger than themselves, and soft material depositing robots that can build in unstructured environments. Most of the press coverage surrounding these little critters is about 10 years old, and ever since, the most significant development surrounding swarm robotics has come out of the UK. That's because in 2022, British startup Hypertunnel claimed to have made the world's first underground structure built using swarm robotics. Coming in at 6 meters long and 2 meters wide, it was a small proof of concept. The company believes that this is just the beginning. The firm proposes a future in which 3-meter-long robots shaped like half-cylinders zoom about underground via pre-drilled pipes. These pipes, which would be about 25 centimeters in diameter, would follow the outline of the proposed tunnel walls and then dig away. First you dig the hole and then add supports or walls to keep the remaining earth surrounding the void at bay. It's believed that such a strategy would use less building material overall, as instead of placing standardized sections of tunnel wall along the entire length of the project,